Hello, parents and teachers who may be watching. Welcome to Creating Math Ahas for Parents. I'm Dr. Sandy Atkins, Sandy. And before I get started, I'd first of all like to thank new subscribers. Thank you so much for subscribing. I really appreciate it. Also, thank you to those who have shared videos or have liked videos or commented on videos. All very much appreciated, and I look forward to seeing comments and those of you who have shared. So thank you. Again, that does help the channel. In this video, we're going to look at just some examples of 2 and 3 digit addition. Now, in other videos, I've shown a variety of strategies. We've talked about 5 strands of math proficiency. So we have conceptual understanding, strategic competence, adaptive reasoning, productive disposition, and procedural fluency. But within the procedural fluency strand, it's about flexibility and efficiency. It's not about showing your child a variety of strategies and then they pick the one they like the best to get an answer. It's not about the answer getting, it's about the playfulness with strategies. It's about knowing when strategies are more efficient with certain problems than with others. So there will be other videos you can watch that will give you a lot more information on that. For this, you can see I've got 4 different problems that I've written, and all I did was use a random number generator on my phone, and that gave me these numbers in the order you see them written. Now, I'd like you to notice some things, and this links with that flexibility and understanding that we want your child to have. Notice how I wrote one problem horizontally, one problem vertically, and then see these might even go against the grain a little bit because they aren't aligned. But one of the things that's really important for your child to understand is alignment is not a requirement. It helps us use a standard algorithm. It helps us use those standard techniques we learned in an efficient way, but it's not mathematically required. What is important for your child to understand is that like units have to be combined. It's like combining like terms as they move into algebra. So hundreds are combined with hundreds, tens are combined with tens, and ones are combined with ones. And if I understand it, it doesn't matter where I've written them on the page. So here's what I'll challenge you to do. Write down these 4 problems. You can rewrite them if you want in a way that feels more comfortable, but write them down and see how many different ways you can come up with to solve these problems. And what's the first one that comes to mind? Maybe there's a way that you see this and you think, oh, this is going to be the easiest way to get this answer. And then there may be other strategies that you want to use to combine. So pause the video, write the problems down, and then take some time and solve them. Then start the video again. We'll come back together and look at some of these. Now, I'm going to start. If you went away, welcome back. We'll start with the 44 plus 71. Now, remember I said it is about combining like size units. So we have tens with tens and ones with ones. And you may see, depending upon your child's comfort and what they're used to, if I understand combining like units, you may see your child do something like put the 40 and the 70 together, 4 tens and 7 tens together, and put the 4 ones and the 1 together. Now, you may see terms like use partial sums. So if I were to write it this way, vertically, you might see your child do something where they have 5 ones and 11 tens, and they have something like that. Or they'll have, let's see, a different way. You might see something where they write 5 ones and 11 tens like this, the partial sums. And then they'll combine those to get the 115. Here I did the same idea. I just combined them and used a horizontal way of writing it. I would have 110 plus 5 in this way. Okay. Some of your students, some of your children may draw pictures to go with this. So the first one, I usually have them draw what looks like a tally mark, but we've used base 10 blocks in other videos, and this is a shorthand way to draw some of the base 10 tens with the 4 ones, and I use dots. Now, you may see in some of your children's classrooms, they're drawing rectangles, a tall, skinny rectangle for the tens, a square for the hundreds, and little squares for the ones. I tend to do this because I have found that when children are drawing rectangles for their model, after a while, all of the rectangles start to look the same. So I use dots for the ones, these rods for the tens, and squares for the hundreds. And then we draw a cube for the thousands. So in this case, you notice when I was doing this, 4 tens and 7 tens gave me 11 tens I kept talking about. So you may see in some of your children's classrooms them writing first the number of tens they have and then the number of ones they have. And then after they write it, they put that together and still end up with 115. Now, with these, there really is no regrouping involved, right? We can talk about the number of tens and another way to make 11 tens. What's an alternative way? Well, I could make it with one of the hundreds and 110, and then the 5 ones. So all the work your children are doing with base 10 blocks, it's helping them understand equivalent ways to write the same number. So these are some things you may see for that first problem. And then we had the 82 plus 85. Now, again, if you haven't, pause the video, try these. But you know, the first thing I saw when I saw this was that double 8, double 80. Now, see, one of the strategies we want your children to do is use what they know for facts to help them do multi-digit addition. So notice how I said double 8. I saw the 2 8s, double 8 tens, I should have said, or double 80. But see, I want to understand that if I know double 8 is 16, then I know double 80 is 16 tens, 160. Double 800 is 1600s. See, once I know a fact strategy and that doubling, I can use it going right on up into the places, or even into tenths and to hundreds and to thousands when I do the decimal side. Now, I could do this similarly to what I did before. I could do partial sums. Now, I can do the sevens. I'll start with the ones, and 16 tens or double 80 is 160, and this is your partial sums. The thing with partial sums that's nice is because I'm preserving place value as I'm doing it, I can start in the ones place or I can start in the tens place. It really won't make a difference. And for some of your children who have a hard time following some of those very specific rules, this is a great alternative for them because it teaches both place value and how to do an addition efficiently. Now, we can collapse these two into one step, and you saw some of that. Would it matter if it had been written horizontally? See, I don't think so. We have 7 ones and 16 tens. What's another way I can make 16 tens? Oh, with 106 tens. So those problems are pretty straightforward. We're not having to regroup from the ones. I'm sure there are other strategies you've thought about. You may see some kids and some folks, well, they're going to think about, well, I'm going to think of 85 as the 80 and 5 more. See, they'll split the problem up that way. They'll end up with the 162 and 5 more, and they'll still end up with 167. As I said, we want them to understand no matter how they do it, they better end up with the same answer. Now, these 3-digit problems that came up, to me are a little more interesting, right? Because there's a lot of regrouping involved. If I were to rewrite this vertically, which might feel a little bit more comfortable to many, right? To many of us, notice when I do the ones, I'm going to have a regrouping situation. Do the tens, I'm going to have a regrouping. For many of us, we see this problem and we think, oh, I need paper and pencil. But one of the strategies that many of your children have learned is bridge to 10 or bridge to 100. And we've looked at that in some of the videos. Now, I want to think about, I'm going to write this horizontally because for me, it'll be easier to show you a way to think about this. And it's a way that helps me find this answer mentally. I don't need paper and pencil at all. Because we want your children, even if they draw out that picture, to understand I could always move one of these over here, make it a much simpler problem, right? So I could find that this is equivalent to 200 plus 127. Very quickly, I can get the 327. See, understanding that is really important. Now, I called it bridge to 10 or bridge to 100, but just as a reminder, if we haven't seen this in a while, see, I can think of 128 as one more than 127. And instead of associating the one with the 127, I'm going to associate the one with the 199. This gives me the 200 plus 127, or the 327. Okay. So for those of you whose children are learning what's called a bridge to 10 or a bridge to 100 or a bridge to place type strategy, the reason that's a really important one for them to learn is it's the associative property. And they might not see this notation early on, but that is what's taking place. And it's easy for some of your children to make that transition to the notation they will see when they are using the associative property. So one way to do it, in my mind, it wouldn't matter how it was written. I know I have 199 plus 128, same as 200 plus 127, 327. Do it in my head. Now, for some of you whose children, they just want to write it down immediately anyway, no problem. And remember, we can still use partial sums if I understand hundreds go with hundreds, tens go with tens, ones go with ones. And as with our previous example, we can either go left to right, start with hundreds, or right to left, or even think about it here, as long as we make sure we combine ones with ones, tens with tens, hundreds with hundreds. So here, 100 and 100 is 200. 9 tens and 2 tens is 11 tens, or 90 and 20 is 110, or still 11 tens. What's another way I can make 11 tens is with 100 and 110. And what's 9 and 8? 17. Now think about, here's a bridge to 10 I can do too. 9 and 8 is the same as 10 and 7. What's 90 and 20 the same as? 110. I can keep using the associative property to even combine these values. So once I've got this, I've got the 300, the 20, and the 7. And as I said, we could have done this problem partial sums the other direction. It should not matter how I do this. I will still end up with 327. So this problem is nice because it gives us that opportunity to remember the associative property. Now, if you haven't done it, and again, remember with each of these problems, I just used that random number generator on my phone, and these were the numbers I got. The first set, I was generating numbers between 10 and 100, 10 and 99. The second set, I was doing it between 100 and 1000, or 999. Okay? These are the problems. Now, again, if you haven't, pause that tape, try it. pause the video, I guess I should say. Try it, see how many different ways you think of, or if you start to use one of the strategies we've already talked about. Now, in this one, if you did pause, welcome back. See, this makes me think, oh, I want to get to 800. That'll be easier to deal with. Because if I get to 800, now I have a double in my hundreds place. It's back to the problem we worked on. That was 85 plus 82, I think, right? Notice how I'm not bothered by where these numbers are written because I understand hundreds have to go with hundreds, tens with tens, and ones with ones. Now, I know that I could take 5 from here and give it to here to make the 800. Associative property, but I could rethink of this as 800 plus 871. Now, notice how I'm still writing it staggered. It's not required. I could have aligned it. I could have written it vertically. That's no problem. But now notice the 800 and the 800. Again, I'm using a fact to find this. If I know double 8 is 16, double 800 is 1600. And one way to make that 1600 is with 1,000 and 600s. See, but just using that partial sum, I end up with this, which takes me to the 1,671. Okay. Now, again, if you want to see what this looks like, notationally for that associative property, see, essentially, I am going to think of 876 as 5 plus 871. Still 876. But instead of associating the 5 with the 871, I'm going to associate the 5 with the 799. Notice my language I keep using. That's important. I haven't gone into a plus, quantity. I haven't been using symbol language. I've been trying to use a very conceptual language to build that number sense. So here I end up with the 800 put together with 871. See my double 800 there? But this is associative property. But your children, depending upon the grade, may be hearing it as a bridge to strategy. But that's just foundational for the properties that they'll be doing as they move up through the grades. Now, it may be easier to see it this way. Seeing the double 800, the 71. Mathematically, there's nothing wrong with that, right? I see it, and notice how I saw it as 71, not 1716, because I'm trying to always preserve place value or do it as much as possible. I don't want place value to only be taught in place value lessons and teach computation separate from understanding place value. It just has made much more sense and seemed to be much more valuable if I combine the two together. If I can bring it all together for the children and help them see how place value is coming into the computation they're doing. So I hope that makes sense. I hope you found it useful. Remember, it's about flexibility, understanding a variety of strategies, understanding place values role as we do this. If you found this video useful, I hope you will give it a thumbs up, share it with others. Also, please consider subscribing to the channel if you haven't already. It really helps the channel out. And thanks so much for watching.